struck me, though, is that both are about creating different types of workplace, or different, in the case of the Limberlost building, it's a learning building, but it includes workplace, obviously. And I wonder if there's something specifically appropriate in using timber for creating the most congenial workplaces possible.
I'd like to say that there are a lot of studies, apparently. There's a Japanese study, there's a Finnish study on biophilia and our relationship to being around natural materials. I find as architects, we have to become forestry experts and sustainability experts and all of that. So I don't profess to say that I know what those studies actually say. But I will say that as an architect working with timber, you cannot help but think about where it comes from. You cannot not engage with the forest. You cannot not think really responsibly and connect actually with the natural environment that you are actually working with. I'd like to think that making spaces out of natural materials and materials like timber, that will transfer to those individuals who are in the building. I think that perhaps there are healthier environments, but I'm not sure. I will say that I think that your sense of connectivity to the natural environment would inherently be there, and hopefully a respect for where the material comes from.
It's a bit like how water, even a quite small stream of water, can evoke notions of water, of rivers, of lakes, even of oceans. But Andrew, intuitively, you've done quite a lot of timber buildings. Do you feel there's something that you feel comfortable with as a designer in using it for the best sort of workplace, or indeed possibly living place too?
No, definitely. And I think, one of the journeys that we went on with our client on this project was to rake up some of that research that Carol's talking about, and to be able to demonstrate to our client that people that work in timber buildings have, lower blood pressure and better concentration. Yeah. They have less days off sick, etc. So I think that you're absolutely right, Jeremy. It's that, that natural kind of biophilic response to natural materials is something that benefits humanity. And I think, the inevitable transformation of architecture and construction to timber from concrete and steel, which is what we're going to see in the next few years, I think there are other opportunities within that transformation, and one of those opportunities is about building healthier buildings to live and to work in, as well as kind of better construction sites and better working conditions, prefabrication, all those advantages that timber has. But the natural material, I live in a CLT building as well, and I sleep well at night.
Yeah, and of course, in London for centuries, you couldn't use timber as within 4.5 inches, whatever that is in millimeters, 225 millimeters, the front face of a wall as a response to fire. Has that changed?
Yeah, we have fire engines now. So, and a fire brigade. Yeah, and and sprinklers, and global research into how timber behaves in fire in different situations. Yeah. And so I shouldn't have answered that so flippantly, but we're very in touch with that research. We have on this project, we had a fire engineer, and the fire engineer had a fire engineer. So that's something we're incredibly careful about and go into lots of kind of detail on.
Carol, has this been an issue in Canada, where I guess there's more use of timber for historical reasons?
Well, no, I actually would. In mass timber, there's not a lot of use. It's actually just it's a really nascent industry in Canada. I will say that the codes are changing. We have new codes that allow for encapsulation and allow for other ways of using timber, but typically in residential and commercial uses. Getting Limberlost approved was sort of like landing a person on the moon. we really had to, in an assembly occupancy building, have not only a fire engineer and an advanced code engineer to actually demonstrate the life safety of this building. That was all peer reviewed by Arup and Associates. So it was belt and suspenders. And so we have a lot of mitigating measures for this building to demonstrate its safety, even though the wood is actually oversized for char, which is one of the mitigating methods that we use. So basically, wood burns very predictably. So it burns at a rate that we can have a 2-hour fire rating and never actually get to the structural part of the wood. The fire will put itself out because it will char if anybody's ever tried to light.
It creates its own sort of protective shell, doesn't it?
Yeah, we also have 2 connections to the fire system, increased amount of sprinkler density, and decreased travel distance. So this was all part of a negotiation that we had to go through to get this building approved. And again, it unlocks possibilities for other buildings all around the world because it is 3,400 people in this building in an assembly capacity. So hopefully it can unlock other possibilities.
Sure. That's quite a lot of people in the building.
Yeah.
In effect, 3,500. But it also shows, I think, that the unlocking of timber, which is one of the oldest construction materials in use, requires quite sophisticated analysis and data analysis in order to use it to its full.
Yep. Absolutely. I think that. Go ahead.
Yeah. Well,
No, it's just nodding. I think absolutely.
I'm nodding too.
Yeah.
Yes.
But I think it's interesting because one of the big advances in the last 20, 30 years has been the huge amount of data resource and computational resource, and in some cases that's gone into parametric design and doing increasingly sort of strange shapes of concrete. But actually, what you're doing is saying no, we can go back to a very basic material which a lot of people feel very comfortable with, and we can actually analyze its performance in a way we haven't been able to do before. I mean, maybe out of experience. You talk to a 17th century carpenter, and he probably knew that actually it behaves quite well in fire, but it was trying to convince other people that it did.
I think you really hit the nail on the head, actually, because I think one of the beautiful things about building in this material is that you're building with a rudimentary material, a very natural material, but the process of design and the process of construction and of manufacture is incredibly sophisticated.
Yeah.
And so we're using the modeling techniques that we're using, the testing techniques that we're using, the construction and engineering is so sophisticated, and yet beautifully it's this replenishable natural material that we're working with.
Yeah, and it's easy to work.
Really?
It doesn't take a huge amount of energy to cut the timber, or compared to what it takes to pour concrete or to cast iron. Or
we put a new staircase into a 6-story office building a few months ago in 10 days. 2 people with a circular saw and some chalk.
Yeah.
And that's a new staircase in the building.
Yeah. No, I think that's fascinating, because I think what it shows is that we can actually go back to these. And I loved your, the handful of seeds is actually all it took. Now, how long did the trees take to grow? Which have been, 30, 40 years possibly? But
it's a little longer.
It's not an enormous length of time. I mean, if you think how long it takes to form stone,
absolutely.
talking about hundreds of millions of years.
Yeah.
So I think, and then and Carol, you were talking about, sustainable. You get your timber from Quebec because presumably that is where, there's a sustainable forestry industry there.
So Canada sources most of its commercial lumber from national forests that are regulated by the federal government.
Yeah.
About 90% of the wood in circulation in the construction industry comes from those forests, which are subject to forestry management plans, which requires decade-long plans that demonstrate protection, conservation, and regeneration of the forest. There are limits on the caliper of trees that they can harvest and the quantities. So this is what managed forests look like. But I just wanted to add one thing to what you were talking about in terms of working with an older material, a material that's been used in buildings for forever, and you think about the handcrafted precision of, say, Japanese joinery in buildings. And that is actually what we're dealing with now, but it's cut by CNC. And so the tolerances for timber are 2 millimeters. For steel, it's 5. And for concrete, it's 50.
Yeah.
So we're talking about an incredibly precise material. And one that can just fit together in the most beautiful way. I loved your construction imagery because these timber elements are just sort of plucked off of a truck, and they're clicked into place with a minimal work crew. They're quiet for the neighbors next to construction sites. So the 2 active construction sites that I go on now are just, they're so pleasant and they're so quiet. Yeah. And I actually feel like they're warmer. I don't know if they actually technically are, but I feel that they're not as cold as the other job sites I go to.
So in all sorts of ways, it becomes an ideal urban material, because if you're causing less disruption, you've got less delivery, you've got less sound pollution for neighbours. But is it really 872 pieces of timber?
Yes.
Really?
Really, 800. I mean, that's the beauty of a BIM model.
Yeah.
872 and 14,200 screws.
Yeah. So you can be that precise. Yeah. Because you can predict it.
Yeah. And then if the building ever comes down, then we have a digital twin for that building, and the client can, sell the pieces of their building to other people to build buildings from.
Yeah. So it can be completely reused.
Absolutely.
Yeah. What's the next frontier? I mean, Carol, you're presumably working on more, mass timber buildings. Yeah. Where will you go? Taller, bigger?
I would love it to be considered for every building that we work on. I would love as well for timber to be, and one of the reasons why we used the opportunity of an international design competition for Fast Inept to explore an innovative system that might attract others, is that we would like other developers, and not even for ourselves. We barely do any residential or commercial work. Our work is mostly public work, but we chose this opportunity to actually see how can we attract somebody to look at a 12-meter a grid, which is usually the commercial grid, because we want everybody to think that it's not a limiting material, but it has opportunities. So for a developer, they may be more interested in having, distribution, flexibility, giving them back space, height. And so we used the opportunity of this international design competition to come up with this flat system and make it public, so everybody can say, why not? Let's look at the cost value analysis of this.
And your slab at 405?
405.
And that's spanning what, about 9 meters?
9 meters.
Yeah.
9 meters, 405 millimeters.
And to go to 12 meters, what depth would the slab be?
Here's what's interesting. Others, construction company in Canada and another architect has already built off of our research and come up with a system with a pre-stressed concrete beam embedded into a similar slab, and they're spanning 12 meters. But they've patented their research. They're perhaps smarter than me. But so this is just to unlock the research so that we can continue to grow this. Yeah. I think doing an all timber building next would be something I would dream of. Right now, all my projects are hybrid.
Sure. And Andrew, where are you going with timber construction?
I think that the reason why we build in timber is because of sustainability and because of the climate emergency. So I think that we need to evaluate each project in those terms before we think about building it in timber. So when it comes to tall buildings, I think we need to think very carefully about how sustainable tall buildings are. And so I think it's about understanding what kind of architecture a new material will present. What kind of architecture, because we're still largely building concrete buildings out of timber. We're designing them out of concrete in our minds in concrete, and then and so many people come and say, oh, we wanted to do it in timber, but it didn't really work for the design. It's quite a common line. We think, well, actually, then you need to redesign it. not change the material.
So it's almost going back to Lee Khan, who held a brick up and asked it what it wants to be. You're going to hold a tree up and say, "What do you want to be? When you grow up, you're going to be a building. What sort of building would you be?"
We generally hug them.
Yeah, that's the king.
Absolutely.
On that topic, I just wanted to mention one other thing that has recently come to us, and it is the ability to convince a client to keep an existing building, because they wanted to take it down and rebuild a building in steel or concrete. But we were able to, because timber is lighter, show them that they could add stories to the existing foundations of this heritage building that they had acquired through a site. They were looking for permissions to take it down. So the embodied carbon in retaining that building at the base and being able to build on top using timber and still get the density they required, that was a real win. And that was only possible because of the lightness of the timber construction.
And I guess, that's a very interesting point. You can actually persuade someone against their expectation to use timber, because I suspect that with, big corporate clients, they're going to think, well, a timber building, it doesn't look quite proper for a high-value commercial building or a hotel or something. So there's a process of education to go through there. But this research that shows that people are happy. Think of hotel rooms. And you said, well, the likelihood is you'll sleep better in a hotel room in a timber building than in a monolithic concrete building. And intuitively, I would think that's probably true.
Yeah.
But when for a hotel operator operating millions of hotel rooms across the world, that is going to be quite a big ask to get them to understand that.
No, absolutely. I think it's a lot about, for architects, I think it's a lot about reframing where we see success as well, and that actually, that it's not often in architecture that you hear the notion of a successful hotel room being one that you sleep really well in. A successful hotel room for an architect is a nice white box with kind of really crisp, like white marble. But actually, it should be about a room that you can sleep really, really well in. Yeah, that would be like the first way to...
And then you pay more to be in a room where you would be going to sleep better.
Yeah. And hopefully it's nice and crisp as well.
They've got a good bar.
Exactly.
So anyway, I think this is a fascinating conversation. And I think in terms of what we're doing with the WAF program, which is to think about how architecture can address the future. And I think the points you're both making are really relevant to that, which is, it's not that everything we know about architecture and we thought about architecture over the course of our careers or our lives or whatever is wrong or has to change. It's that we can learn from it and we can direct that towards the future in a much more constructive way, using modern tools like digital technology and using that to reassess how we think about traditional materials like timber. And it may be in 20 years' time, we really will have worked out how to decarbonize concrete or steel. I'm not, I wouldn't make a prediction about that. But I think at this stage, timber, offers something that those materials don't offer in those terms. So thank you very much. Can we thank our speakers?